in this very first podcast in the series, we're going to open up our studio and start working with R for the very first time. So as per the instructions in the documents, you're going to have installed both R and also RStudio. So RStudio is just a front end to let us access R in a much more friendly way. So when we open up and click RStudio, we'll get a window like this. I'm working on a Mac for the duration of all these podcasts. The Windows terminal or interface looks almost exactly the same. And what we'll see here is when we open it up, we get something that looks a bit like this. There will be somewhere a console window here. So this is actually R. So this is where we will interface with R. And R is in its heart hidden away as a sort of terminal or console application. And there are various front ends to that. And RStudio is one of these front ends that tidies the whole process up and makes it a lot easier for us. So one of the first things you'll notice is when it loads up, when RStudio loads, it will tell us something about the R version that's installed. So this is R version 3.4.1, which is up to date as of today. So we're in August in 2017. So it's worth bearing in mind that R updates about twice a year, typically at the end of June and the end of December, I believe. So it's worth bearing in mind that RStudio will not tell you that R is out of date. You're going to have to do that a little bit manually yourself, and remember to check that. So it's worth setting a calendar reminder or something, or at least bearing in mind that at some point you're going to have to go back onto the CRAN website and download R again. Otherwise you'll find some of the packages you might be using and depending on won't work. What else have we got? So the other thing to bear in mind is that RStudio up here has got updates, so we can check for updates, and you can update RStudio separately as well. And again, it's worthwhile just running that every now and then to make sure you're up to date. So what is R? Well, R is this. R is this up here, as you can see, this black screen, and RStudio tidies it all up. So as we work through the podcast, we'll see all these various different options, and you'll see there are different layouts possible as well. So here I've got my console window here on the right side in the top right hand panel, the pane. Down here, then you've got a tab for the files. So this shows you the files on your computer, and ultimately we will use this to set projects where we'll define specific folders in which we're going to work on data analysis in later podcasts as we move through the program. Any plots or figures that we create will appear here in this pane. The packages tab tell us all the possible packages. These are add-on functions and scripts for R that really make it very powerful. So this will eventually then list all the ones that are possible that I have installed locally and that we can load up when we require them. Again, we'll come to that later on. Help, this will be hugely useful at some point for us. So this will provide sort of help or instructions and examples for how you would use and call various functions in R. Again, we'll come to that. And the viewer pane then is somewhere where either the output of some of the markdown, so these HTML files that support this module, that's where these would appear when we build them, again with RStudio. So what else have we got? So over here then we've got what's called an environment tab. We'll see things, there's nothing in it at the moment. The environment is currently empty. We'll see that will start being populated as we move through today's example. And the history command has a history of all the commands that we typed in that were sent or evaluated here in the console over the last session. So that just records there. That's my history and stuff that I've been working on. To be honest, I don't really use that very much, and I would caution against relying on the history pane to store your work, and instead we'll store our instructions as scripts, and those scripts will appear ultimately in this pane here. So I got that there. So that was hidden from us originally here. We just had the environment and history. I pressed this little down button here, that jumped down, and it's created there's a blank script file here that we can type instructions into, and again we'll use that later on, and those instructions will be stored and saved in a text file. And we'll then, when we want to rerun those, we'll send those commands over here to the console window where they'll be evaluated, and the results will appear here in the console window or here down in the plot pane here. So all this layout, you can customize this layout. You can choose where you want your panes to be. I like working like this because normally when I work, my screen usually looks something like this, where I've got my script file here that I'm actually working on and I'm typing instructions to. Those instructions are then sent over here to the console window, and the output of those might appear here in the plot pane down here. So this is normally how I work, with just these 3 panes like this, and I like these to be beside each other. But you can change that any way you want. If you go to the RStudio preferences and you go to the pane layout here, you can choose which ones appear, which different combinations you want them to appear, and where you want those different windows to be. You can also change the appearance. So I like this dark. I like the dark backgrounds to work with the sort of the neon almost colored options, and that's called Tomorrow Night Bright. There's also, there's basic. That one's slightly different variation on a theme. There are many. So there's white ones as well. That's probably the default in your options. Maybe the Crimson Editor or something is the default. But I'm going to go back to Tomorrow Night Bright for mine. So before we start actually using R to do anything particularly useful, it's basically just a giant calculator, and that's all it is. So up here in the console window, we have a prompt here, a little command prompt with a little flashing cursor, and into this console we can type instructions directly. So you can do simple sums. So you can do things like 2 plus 3 is 5. You can do things like 18 divided by 3 is 6. You can have 5 times 3 is 15. You can have 2 to the power of 3, which is 8. So there's all these different operators we can do, and you can use parentheses then as well to separate them out. So you can do, if you wanted to go 2 to the power of 3 minus 1, so that would be 3 minus 1, it'll do that first because it's in the parentheses there, so that'll be 2. So 2 to the power of 2 is 4, and so on and so on. So that's what's phenomenally useful way for us to just do some basic sums and some basic arithmetic. But where R gets really useful, like any sort of computing language, is the ability to assign numbers or values or things to other objects, so to names of things. So the example I like to use is that of a shopping list. So we can construct a shopping list. So we can say an apple is equal to. So this sign here, we read this as equals to. In R, you can actually write equals. You could write apple equals 0.63 cent. So an apple is 63 cent, 0.63 of a euro. But the best practice is actually not to use the equals because it's used elsewhere, but to use this assignment operator, it's called. So this arrow is basically it's this less than symbol, and then it's a hyphen, and that is an assignment. So it's basically saying that the 0.63 value goes as an arrow point into Apple. So Apple takes the value of 0.63. So now a couple of things have happened. So we've what we've done is taken the value 0.63 and stored it into something called Apple. And now if I type something called Apple, it will return the number 0.63. The other thing that's happened, we can see over here in the environment pane, is all of a sudden now the environment is not empty. Now there is something in the environment. There is an object called Apple, and it has the value 0.63. Then we can do that with an orange. So an orange is, say, a little bit more expensive. It's 0.75 cent, like that. So now we've got orange and apple in the environment. Apple is 0.63, orange is 0.75. And now we can start doing sums with apples and oranges. So you can start saying, well, how much are 3 apples? Nope. Okay, so I've typed 3 apples. It said error, object apples not found, and that's because there's nothing called apples in the environment. The thing is called apple, and R is very sensitive to this. It is both case sensitive and very strictly sensitive to what you type and what you call an object. And that's a good thing, but it also means you've got to be careful that you type 3 times apple. So apple times 3 is 1.89. We could make a bigger shopping list, so we could create a shopping list which is maybe we want to buy 8 apple and 6 orange. So 8 apple and 6 orange is 8 apple and 6 orange is 9.54. So it's €9.54. The other great thing here we can see with RStudio in particular is if we start typing, so we start typing shopping, if I pause then for a second, it'll give me a whole load of options of things that it'll guess and match with, try and predict what I'm typing. So here in the sort of the purple symbol, it lists objects, so that's shopping list, so that's what actually we want. The other things listed are actually functions, so these are green, so these are functions. We'll come on to seeing those later on. So we've got shopping list there. If I press tab, it will auto-complete that, which makes things much easier to type. And that returns our shopping list again at 9.54. So that's also appeared in our environment here as well. So we can add things to the environment. That's what we've learned to do. You can also remove things from the environment, and we can remove them with a function called rm. So rm is a function in R, and to apply a function to something, you type the name of the function, the roundy parentheses, these rounded brackets, and then you put something into it. So if I put apple into that, it will remove apple from the environment. Sure enough, over here, apple has been removed from the environment. Now if I type apple, it says error, object apple not found, and that's because it's gone. It's no longer in the global environment. So what we can do as well as recall ls is another function. It's called list, so it'll list everything that's in the environment at the moment. So it lists the list ls, so what's in the environment. There's something called orange and there's something called shopping list. So we can combine those two functions now, and we can say remove ls, remove list equals ls. So this will remove what? It'll remove a list of things. So it'll remove everything basically. So ls will return orange and shopping list, and remove will remove all of those from the environment. So now everything is gone. We've got a clean environment again here. The global environment has no objects in it. A slightly more normal example of what we might do. So I'm just going to hit the return a few times to move that up the screen. So what we might want to do is typically R would be used for analyzing data or working with data. So we can add some data. So we're going to create a small little data set, which is a series of weights of mice. We're going to store it into something called mouse.weights. We're going to create a list. So I'm going to use this C. C is a function. It's short for concatenate. Concatenate just means put things together into a list or a vector. So we'll type in these numbers here: 16.6, 12, 10.9, 15.9, 25, 14.5, 18.2, 13.8, 21, and 21.5. That's all of them there. Okay, so now we've created something called mouse weights. If we look over here into the environment pane, we see mouse weights is, and it says it's now a numeric. It's a numeric vector. So it's a vector. It's got 10 entries. So it's a vector from 1 to 10, and it shows us those there that we can see. If we go back up to the console now, if we type mouse.weights, it'll return those numbers for us. So now we can start doing something with these numbers. So one of the things we can realize is that objects have different properties. Not all objects are the same. Mouse weights is numeric. If we created apple again, so if we made apple is 0.63 again, see, apple is not a numeric apple, so we can try and work out what these are. The class function will tell us what they are. So mouse weights, the class of mouse weights is numeric. It's a numeric vector or a list of numbers. So we see that apple actually is a numeric as well. Apple is numeric, but it's sort of a special kind of numeric. It's a scalar numeric, so it's just a single entry. It's not a vector, so it didn't tell us that it was numeric from 1 to 10 here over in the environment. But there are other types of objects that you can create. So you might want to store something as a text name. So you want to say you might want to create something called my name is Andrew. So if we then, you'll see that there's a thing now in the environment called Andrew, and it's an object called my name, and it stores the value Andrew. So the class of my name is a character. So it's not a number, it's not a numeric, it's not something you can do maths with. It's just a character string of letters. And as we move through as we move through this whole program of the various podcasts, we'll see there's lots and lots of different classes of objects available. So one of the more useful functions to work out what objects are is str, which will strip out it'll pull out the structure of an object and tell us more details about it. And we'll particularly see when we start working with larger data sets that this is useful. So str, structure of mouse weights, again tells us the numeric 1 to 10, and it's given those values there. It's given the first suite of values. If it was more than it wanted to print, it would only show us the first few of them. So now that we've got our mouse weights, again, so we've got these numbers, we've got these 10 numbers in here of mouse weights, we can start doing some more useful things with this. We can start calculating some summary statistics of it. So we might want to know, well, what's the mean? What's the average weight of our mice? So the function mean, again, so we said mean of mouse weights, it'll return 16.94. So the mean weight of all those 10 mice was 16.94 grams or something. We might want to know, well, what was the smallest one? So the smallest would be min. So minimum of mouse weights is 10.9, and similarly the max of mouse weights is 25. So the largest value in there is 25. We might want to know what the range of mouse weights is. So the range is basically the min and the max, so it's giving us the smallest to the largest value in that vector, that string of numbers. We might want to know what the standard deviation is. The standard deviation is SD, so standard deviation of mouse weights, the variance of the mouse weights, and so on and so on. There's lots and lots of these. The median of the mouse weights, 16.25. So we can get all these sort of summary statistics that are useful to describe and summarize a whole pile of numbers. So similarly, we might want to know, so for example, in that min or max one, we might want to know, well, we know what the minimum mouse weight was, but we might want to know, well, which mouse had the smallest value. And that's where a function like which.min of mouse weights is 3. So it's telling us the third entry in that list of, in that sort of numeric vector of numbers, the third entry was the smallest one. So we can access that. So mouse weights, and now we're going to use square brackets. So when we're using a function, we use roundy brackets. When we want to access the contents of an object, typically, especially a vector, we'll use these square brackets like this. So there's square brackets, 3 will return us the third entry in that mouse weights. So let's just see that again. So mouse weights is a numeric vector of 10 numbers, position 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So number 3, we asked, well, which is the min, which is the minimum value? It's the third entry. And the third entry is 1, 2, 3, 10.9, and we can extract that one using this line that we used here. So I'm just going to use my arrows here, so I can use my cursor arrows to go back up through the values I typed into the console. So if I go up twice, I'll get mouse weights.3. So the third entry in mouse weights is 10.9. And similarly, we could sort of shorthand this again, so we could do the same for which.max mouse weights. So which.max mouse weights, I presume, is going to return the largest one. So that's going to return the largest value. It's going to tell us which one is the largest. So it's going to be 1, 2, 3, 4, 5. So the fifth one is the largest that I can see there. It's the fifth one, and it's got the value 25. So mouse weights, which.max mouse weights, we can combine these function within an address of a vector, tells us the value is 25. If we look at that, take that apart and deconstruct it, so which.max mouse weights, I think, is which is the largest, so it's going to be position 1, 2, 3, 4, 5. So I reckon that's going to come back with the number 5, so which.max returns 5. And sure enough, that lets us extract and pull out then the maximum value. So that's really useful if we want to find out, well, which of our individuals is the largest, or which of our individuals is the smallest, or which of our individuals has a certain property. Functions like this let us pull out and extract those particular entries in a data set. R is also full of really useful shorthand functions. So we saw there earlier we could calculate the mean, the min, the max, etc. and all the rest, but there's a really useful function called summary, and that will let us pull out just a whole range of different summaries. So summary returns for us what the minimum is, what the median is, what the mean is, what the max is, and also then what the quartile ranges are. So this is the first quartile range. It's a measure of the sort of the spread of the data. So 13.97, and the third quartile range is 20.30. So what that means is that 50% of our data falls between 20.3 and 13.97. So 50% of the data falls between those two intervals. And then the whole load of the data falls between these two intervals. The mean of it's 16.94, and the median is very close at 16.25. So we want to see if we want to get some help on a function, you can use the question mark. So this is something really important to learn, is how to get help. Getting help is learning to help yourself, and learning to navigate the help files is a really important skill in R, because this is what's going to let you augment things that we show you here in these podcast series. It's going to let you make some changes, customize things to your own self, and it's also you can also often guess at what a function is called. And if you can guess what it's called, you can type the question mark and get the help function for it, and then you can check that the function is doing what you think it's doing. So there's functions called summary, so we can type question mark summary like that, and that pops up then here into the help pane, the help file associated with it. Now, some help files are more helpful than others, and some of the help files in R are famous for being, or infamous for not being particularly informative or helpful. But you can usually, you learn to be able to find your way, navigate through them, and make sense of what it says. So this says, summary is a generic function used to produce result summaries of the results of various model fitting functions. Function invokes particular methods which will depend on the class of the first argument. So what summary actually is, summary as a generic function, summary is kind of a clever function. Essentially, it will look to see what class the object is that you've given it, and it will return a summary that it thinks is appropriate, or somebody has programmed to be appropriate for that class. So if you give it a vector, as we did, it gives you the min, max, median, quartile range, etc. If you gave it a larger data set, it will try to do the same thing for all the different columns of the data set. We'll use that definitely later. If you gave it the output of a model fitting object, if you tried to estimate some sort of like linear regression model or an ANOVA model or a t-test, and you ran summary on the output of that, it would give you a completely different output farm that would be useful to and designed to give you information about the results of the statistical model or whatever it is that you've done. So summary is a clever function that looks at the class of the object and returns an appropriate set of results for the class of object that you've given it. The help files for mean are probably a lot more straightforward. So help files for mean is a generic function, again, for the arithmetic mean. Mean takes a vector or a value of x, an R object. It says here x here is an R object. Currently there are methods for numeric and logic vectors. So we've seen numeric, we haven't met logical, but we will later on. If it sees it's a date or a date time or a time interval, it will also take those and try to do something clever with those. By default, there are other options with mean as well. So we only just gave it the mean of that, but it is set to trim as 0. So this will remove values and trim them out. Normally, I never go near that, to be honest myself. Just leave that at 0. So that defaults to 0. So I just ignore that and never call trim. But the na.rm option is an interesting one and a useful one that we'll see later on. An NA is like a missing value. So na.rm is a logical value indicating whether NAs should be stripped and removed before the computation proceeds or left in there. If you leave them in there, NAs tend to propagate. So if there's one of these was a missing value, so if this value here of 10.9 was actually a missing in NA, and we calculated the mean on that, it would leave it in there, and then it would return the mean would be NA, because any NA in there, if you add an NA to something, you get more NAs, and the whole thing will add up to an NA, and then you'll divide by an NA, and it'll return an NA. So if we were to set na.rm to be true instead of false, it would then remove that value, the NA, from the list, from the vector first, then it would calculate the mean. So it's important to bear in mind that if you have missing values, you might be calculating a mean on 9 values, not the 10 that you gave it. But also you've got to bear in mind that you might have to tell it to miss and skip and remove those NAs. Then there are further arguments. We're not going to deal with that now, but potentially someone could write another mean. There might be a mean of a date time object that for date time had more options and more availability for you to customize it. So you could pass further options on to those appropriately. But normally we would just use mean of x, so mean of a vector of x, and we probably would oftentimes have to use na.rm is false or true ourselves. So that kind of is the basics of kind of working with the console window, looking at using R basically to create and store numbers as vectors or as scalar numbers in objects, how to interrogate objects with functions to get summary statistics of them. And we'll take a quick break there from this podcast, and we'll pick this up immediately again in a second podcast. It'll be quite short. It'll just run through some basics of some simple plotting and how to make some figures in R. So, but I think this is a good place to stop for now.